Good afternoon, class. We are looking at Chapter 5, Trigonometric Functions. Here's Section 5.4, Right Triangle Trigonometry and its applications. So in this section, the objective would be solve right triangles, solve applications. Reminding you of properties of trigonometry when you have a unit circle, x squared plus y squared equals 1, a pair comma x comma y is cosine and sine. All trigonometric functions are odd. That means f of minus x is minus f of x, except cosine and therefore secant, they are even functions. Fundamental identities, we have Pythagorean identities, quotient identities, reciprocal identities. We looked at sum and difference formulas. For example, sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta, and the rest of it. If we replace the beta with alpha, it gives rise to sine of 2 alpha, double angle formula. As an example, if I put alpha here, becomes sine alpha cosine alpha plus cosine alpha sine alpha, which is 2 sine alpha cosine alpha. And the rest of them follow in the same manner. So we have sine of double angle, cosine, and tangent. Of course, there are different ways of writing it. One way is to with alpha here, tan of 2 alpha is 2 tan alpha over 1 minus tan squared. Now, if you look at this one and solve for sine squared, gives you 1 minus cosine 2 alpha over 2. Cut the alpha in half. Sine squared of alpha over 2 is 1 minus cosine alpha over 2. Over here, you can solve for cosine squared alpha. Cut the alpha in half. Cosine squared of alpha over 2 is 1 plus cosine alpha over 2. And tan squared of alpha, different ways of writing it. One way is sine over cosine, and of course, cut it in half. Take a root to find sine of alpha over 2 and the rest of it. You have plus minus, and you decide which one based on the quadrant. In the case of a tan, you have 2 more ways to write them. In these 2 cases, you don't have to worry about plus minus, and product to sum and sum to product. It's there in case anybody needs it. Now we are going to move on to right triangle trigonometry. We want to solve the right triangle, meaning we want 3 sides, we want 3 angles, certain parts are given, certain parts are missing. So if this is angle A, this is angle B, A and B are the sides, C is the hypotenuse. So this is adjacent to B opposite A. This is adjacent to A opposite B. So the way we call the vertices, okay, A, B, C. So across from A is this side lowercase a, across from B is lowercase b, that's the side, and across from C is lowercase c. So lower cases represent the sides. So having said that, a squared plus b squared equals c squared, Pythagorean theorem. And this is a right triangle, so A and B must add up to 90 degrees because the total interior angles is 180. In other words, we should know A plus B plus C is always 180, right? So this angle is B. By definition, sine is the opposite over hypotenuse. Cosine is adjacent over hypotenuse, and the rest of them follow in the manner that tan, you can write it sine over cosine. Cosecant is 1 over sine. Secant is 1 over cosine. Cotangent is 1 over tangent. And so, for example, this one would be, if you look at sine B, the opposite is B, and of course the hypotenuse is C, so B over C. If you look at this one, the adjacent is A over C. So the adjacent is A over C. and the rest of them are the reciprocal. So this is how we arrive at the answer for a right triangle. Now, as an example, in this case, we want to find the value of each of the 6 trigonometric functions of the angle theta. And that means we want A, B, C, and capital A, capital B, capital C. And these are the information for any right triangle. A squared plus B squared equals C squared, so on and so forth. So for example, here, this side is 3, this side is 5. So we can find this side using Pythagorean theorem. A squared plus B squared equals C squared. So 3 squared plus this side quantity squared equals 5 squared. So we're going to call this side B. 3 squared plus B squared must be 5 squared. And B becomes 4. So if B is 4, sine theta is the opposite, this is theta, the opposite, which is B, over the hypotenuse, which is 5, so 4 over 5. Cosine theta is the adjacent, which is 3 over 5. The rest of them, I mean, for example, tangent is the 4 over 3, the opposite over the adjacent. Okay, 4/3, and the rest of them are just reciprocals. Cosecant, look at sine, 4 over 5, 5 over 4. Secant, 3 over 5, 5/3. Cotangent, look at tangent, 4/3, 3/4. So the rest of them, you go with the reciprocals. Those are the easiest way to come up with the answer. Now we want to solve the right triangle. Two sides, A and B, are given. Okay, so A is 3, B is 2. See, opposite A is A, opposite B is B, opposite C is C. So we have capital C here, just in case. So obviously, two sides are given. A squared plus B squared equals C squared. So 2 squared and 3 squared, we're going to add up. So A is 3 squared, B is 2 squared, and they add up to 13. Take the root of that, and this is the exact answer. Now, since we don't have those two angles, but obviously this is 90, to find them, you use one of trigonometric functions, sine, tangent, cotangent, whatever. Always use what's given. You notice that this one, you can calculate the tangent or cotangent. This one, you can do the same thing, tangent or cotangent, because the sides are given. So the reason I want you to go with the given, because maybe we made a mistake here. So you always use, if possible, what's given. So for example, tan of A is the opposite 3 over the adjacent 2. Or you can say tan of B is 2/3. That's fine. So what is A? Tan inverse of 3 halves. And use a calculator. Tan inverse of 3 halves. And let's say we're going to go with 1 decimal. Normally they tell you 1 is good, 56.3 degrees. So if A is 56.3 degrees, B must be 90 minus that 33.7. And I like to write everything again. So A, 56.3 degrees. This is 33.7 degrees, 90 degrees. C, A is 3, B is 2, and C is square root of 13. This is 56.3 degrees. All right, again, we want to solve a right triangle. Lowercase b, one side is given. Capital A, one angle is given. And we want to find the rest of it. So A is 40. And obviously, the easiest one would be A and B. They add up to 90 degrees, right? So B becomes 50 degrees. Since we have only one side, then we're going to use a trigonometric function. Anything will do. And since 40 degrees is given, we're going to go with that. So tan of 40 degrees is the opposite A over the adjacent 2. Cross product, A times 1 is A, equals 2 times tan of 40 degrees. This is the proportion I'm using, everybody. So cross product, right? Everybody knows that. And so with that being the case, A is 2 times tan of 40 degrees. It's not a common arc. Use a calculator, and then we find tan of 40, we multiply it by 2. So we have A equals 1.68 roughly. Well, we can continue with A squared plus B squared equals C squared, or we can go with sine, cosine, and so forth. For example, again, 40 degrees is given, okay, and 2 is given. You want to use the given to be on the safe side. Cosine is the adjacent over the hypotenuse. So cosine of 40 is the adjacent, which is 2, over the hypotenuse, which is C. And so cross product means C, you can put it here, cosine 40 degrees goes here. You can interchange those. And of course, you put this into a calculator, you divide 2 by it, and you get 2.61 roughly. So we're going to write, this is 2.61. You can leave it as that, but let's just write A is 40, capital B is 50, capital C is 90. A is 1.68, B was given as 2, and C was found as 2.61. Complementary angles, the sum is 90 degrees. If you have two angles, they add up to 90 degrees, they're complementary. Obviously, in a right triangle, A and B are considered complementary. Cofunctions of complementary angles are equal. What do we mean by that? Complementary angles. For sine would be cosine, as long as these two numbers add up to 90. So this must be 90 minus 30. This must be 90 minus 60. Tan and cotangent, secant and cosecant. So what is sine of 62 degrees? We want to write the cofunctions. First of all, for sine, we go with cosine. Secondly, they must add up to 90. So 90 minus 62, which is 28. So cosine of 28 degrees. What about this one? It becomes cotangent. So you're going to write pi over 2 minus pi over 12. Now pi over 2 is 6 pi over 12 minus pi over 12 is 5 pi over 12. So for tangent becomes cotangent of 5 pi over 12. Pi over 4, that means 45 degrees, and the cofunction is pi over 4. So cosine of pi over 4 is sine of pi over 4, because these two add up to 90 degrees. And pi over 3, I hope you know it's pi over 6, because pi over 3 and pi over 6, they add up to 90 degrees, or pi over 2. So cosecant becomes secant of pi over 6. Some application. A surveyor wishes to find the width of a river. In other words, B or AC. He sets up his transit, an instrument that measures angles, at C on one side and sighted across to point A on the opposite side. So that means this is a 90-degree angle. After turning through an angle of 90 degrees, so this is here, turning an angle of 90 degrees, he walks 200 meters, the distance of 200 meters from C, to a point B. And finally, setting the transit at this point, then he measures the angle, and this angle he measures with the transit to be 20 degrees. What is the width of the river? That is the methodology to find it. So what is the methodology? You write from here, you locate a point across, then you turn 90 degrees, and you go some distance. You decide, for example, 200 meters, and you stop and now measure the angle. So obviously, the easiest way, tan of theta is the opposite, which is B over the adjacent, which we purposely went for 200 meters. This is the angle. Tan of theta is B over A. In other words, B over 200. So tan of 20 is B over 200. And that means B is 200 tan of 20 degrees. Of course, you have to put that into a calculator for tan of 20 and times 200. You get the answer. V, or AC, or the distance across, is 72.79, and same units that was used here, meters. Angle of elevation and angle of depression. Angle of elevation is the angle formed by the line of sight and the horizontal plane for an object above the horizontal. So in short, look up this angle is the angle of elevation. Angle of depression is the angle formed by the line of sight and the horizontal plane for an object below the horizontal. In other words, just look down. And now, with respect to the horizontal line or plane always, okay? So a couple of pictures that will help. So the cat is looking at the bird. So this would be the angle of elevation, and the bird is watching for the cat. This would be the angle of depression. The guy is looking up, looking for a plane. That's an angle of elevation. Looking for the animal, looks like a dog, angle of depression. So that's as far as definition. So meteorologists find the height of the cloud using an instrument called a ceilometer. A ceilometer consists of a light projector that directs a vertical light beam up to the cloud. base and a light detector that scans the cloud to detect the light beam. A ceilometer was set up such that its light projector is 300 feet from its projector. Okay. That means the base here. Okay. So this one is the light detector, light projector. Okay. The light detector, okay, is right here with the distance of 300 feet. So a ceilometer was set up such that its light projector is 300 feet from its projector. So this setup is called ceilometer. If the angle of elevation, this one, is elevation of the light detector is 75 degrees. So the light detector reads 75 degrees. Find the height of the cloud. So again, take a look at the concept. This is the distance of 300 feet. This is the angle of 75 degrees. And this is the height we are looking for. So clearly tan of theta is H over B, where theta is 75 degrees, H is missing, and B is 300 feet. Therefore, H is the product of these two. 300 tan of 75 degrees. Putting it into a calculator gives you the answer. 1,119.62 feet. So a quick recap, you have a light projector and you have a light detector. Light detector is in some distance, okay? This is vertical, making a 90-degree angle here, and some distance, you know the distance, you know the angle, you can figure out the height. A statue of Ceres, the Roman goddess of wheat, can be observed at the top of the Board of Trade building in Chicago. So this is the building, and this is the statue. Observation 400 feet from the center of the building reveals that elevation to the base and to the top of this statue are 55.1 degrees and 56.5 degrees. So somewhere here, you look at the angle to the base and to the top. The base is the top of the building and the top of the statue. So this is 55.1, this is 56.5, respectively. What is the height of the statue? So let's set it up. First and foremost, this is the height of the building. Then at top, we have a statue, okay? And so let's say this is A, the very top of the statue. This is B, the base of the building, and C. And what we are looking for is very straightforward, everybody. We want this distance AC. So AB minus BC is AC. We are looking for AC. So to find AC, we're going to find AB. So how do we find AB from the bottom to the very top? Look at the bigger angle. The larger angle is 56.5 degrees. Tan of that is AB over this distance of 400 feet. So tan of 56.5 degrees is the opposite, which is AB, over the adjacent, which is 400. And so again, cross product. AB is the product of 400 and tan of 56.5. You put it into a calculator and you get 604.33 feet. Now the next project would be BC. What is BC? That means the height of the building or the distance from the base to the base of the statue. And again, the smaller one, tan of 55.1 degrees would be BC divided by 400. So tan of 55.1 degrees, BC over 400, and again, cross product BC is 400 times tan of 55.1. Putting it into a calculator with a couple of decimals, 573.39 feet. And again, as far as the number of decimals, you always want to pay attention to what they ask you. So what is AC? The difference between these two numbers, everybody. We put it into a calculator, and AC is 30.94, almost 31 feet, everybody.